Okay, can we take our seats, please? That will empty the room if I try singing. Okay, the only way I think is if we make a start to the session. So, welcome back to the second session of MENOG. I will be chairing this one for you. Marco will be chairing the sessions this afternoon. So he'll be chasing the speakers for this afternoon at some point to make sure that slides are on laptops and that we're all ready to go. So we've got 3 presentations for this second session. First up, we have Raju Raghavan from Tata Communications, who is going to be talking about lessons learned deploying global dual stack and DDoS networks. So, Raju, if you'd like to come up.
So should we get started? Okay, great. Yeah. Okay. So good morning, everyone. This is Raju Raghavan from Tata Communications. And today I'm going to talk about lessons learned and best practices from deploying global dual stack and DDoS mitigation infrastructure, right? So without much ado, I think I'll get started. So the agenda of the presentation is pretty much this. I'll talk about the context, which is the network that I'm really going to talk about. Then we'll talk about a few key global trends, right, that are really very important, and that really form the base of my presentation. Then we'll talk about the Tata Communications network journey and the key learnings, followed by a summary. So the first slide, is the context, right? So this is a map of Tata Communications global network. So just one slide on the context, right? I'm going to not really talk much about the network itself. So quickly, we are a global IP service provider carrying about 6 terabits of internet capacity globally. We have about 219 POPs in 31 countries. We are the 6th largest internet service provider globally, and we carry about 13. We have about 13 terabits of round the globe cable system capacity. Right, so that's just the context, of the network that I'm going to really talk about. So first, before I really, get into my talk, we look at a few key global trends that are, key global challenging trends that are driving innovation in network planning. Right, the first global trend, as all of you would recognize, is the exponential growth in traffic growth. Exponential growth in traffic. In the last few years, what Tata Communications has witnessed in explosive growth in internet traffic, about 70% year-on-year growth, year-on-year growth, and thanks to the YouTube and Facebook phenomenon, right? So this everyone knows. Now, what's happening is this growth is really resulting in shortening planning cycles, right? What do you mean by a planning cycle is, when there's a traffic growth, what do? You kind of typically go and, upgrade the capacity on the network, right? You kind of add some capacity, etc. What's happening is, in the last few years, no sooner did we kind of add a capacity, we already see that, the particular link is already fully utilized, the corridor is already hot, and we have to get on to a next round of planning cycle, right? So the planning cycles for global service providers, and I'm sure it's something that you are also seeing. It's kind of shortening year on year, right? So you have to keep running around, planning for capacity. That's the first trend, right? The second trend, is I would say a slightly it's a conflicting trend, right? In the last few years, what we have seen is, the customers' expectations have gone very high. There is just zero tolerance. Customers just don't tolerance, a second of downtime, right? In 2008, people used to talk about 99, 3 nines, 4 nines, 5 nines of availability, right? But these days, it's just all about 100% availability. No one really talks about 99.9 or 4 nines or something, right? So it is. I would say these two trends are kind of mutually opposite trends, right? On one hand, you kind of you see the traffic is growing and you have to run around planning for capacity. On the other hand, customers are becoming unforgiving, right? So they're becoming more and more intolerant, to any sort of downtime, because more and more businesses are now dependent on internet and network connectivity as a whole. So these are two trends, which again form the basis of my talk today. Now the other one is obviously IPv6. IPv6 we have seen is really taken off. I have a few statistics to share, in my slides. The fourth trend, that is relevant to this presentation is DDoS, right? So these days we are seeing large-scale DDoS attacks. We are seeing 300 gigs of, a 300 gig attack, So we kind of seeing very, very large-scale DDoS attacks, and that is one of the fourth trend that is relevant to this presentation. So now, we looked at the trends, right? So now we will see the impact of these trends, on the service provider infrastructure. So now the first trend that we said was traffic growth, right? So when you plan for traffic growth, a typical service provider, what do you do? The first thing that you do is, you look at the backbone peer, customer utilization, right? You kind of try and see what is your utilization rate. It's the first thing that you do. The second thing that you probably do is you look at flow statistics. You look at net flow, S flow, J flow, C flow, IP fix, or whatever. You kind of identify, the the flow of the traffic. You kind of try to figure out from which geography to which geography has the traffic grown, right? So that is the second thing that you look at. The third thing that you sometimes look at is, is it an encrypted flow? Is it a layer 2 flow or a layer 3 flow? Is it a giant flow? Because these flows, have some typical characteristics. They cannot be load shared, right? So you cannot like add multiple links if it is a giant flow, right? You have to add, upgrade the capacity, and you will not be able to load balance, etc. So now I'm just talking about simple stuff. So then what happens is then what do you do? Then on the data plane you kind of add capacity, right? You've identified that this particular corridor has good amount of traffic growth, and now you kind of add capacity. You add 10 Gs, 40 Gs, 100 Gs, and STM4s, STM16s, STM1s. Depending on a particular situation, you kind of add capacity, right? So that's something you do. And then what you do, sometimes, if, instead of adding capacity, you have to also add, load balancing. You kind of add lag links, you do ECMP, those kind of things, right? So, if it's a layer 2 flow that cannot be, load balanced across multiple links, you have technology features such as entropy labels and other labels that you have to really look at, to kind of, load balance traffic across multiple links, right? So this is the typical, a step-by-step process that you follow, when you have to plan for traffic growth. When you have to plan for zero tolerance, right? So when customer says, I'm going to be unforgiving, I just cannot take even a second of downtime, what do? You typically look at, I'll kind of discuss why. You typically look at some of the control plane parameters, right? You look at CPU utilization, you look at FIB utilization, which is forwarding information base. You look at multicast FIB utilization. You look at label fib utilization. There are so many different, kinds of memory, right? So you look at layer 2 fibs, and you look at, whatever, QoS, TCAMs, adjacency, you look at, BFD, network processor scale. You kind of typically look at a lot of, control plane related parameters when someone says you have to now plan for zero tolerance, right? So that's something, so then after looking at it, then what you do, you plan for, some of these, some of these features that will kind of help you, work around these failures, right? So you look at fast SPF calculations. You look at, features, such as BGP add path. You kind of turn on BFD on the network, right? You want faster detections. Now you have Ethernet. You have features such as best external. You have these novel features such as LFAs. LFA stands for loop free alternate. That can help you converge your network much faster, right? So there are all these features, control plane based features that you kind of turn on when planning for zero tolerance, right? So if you want to build a network which is absolutely, resilient to failures, you also need, you have to look at the control plane aspect of it. And then, what we have seen in our network, this is more coming back to the Tata Communications network, is, many a times we plan for this network growth, and then we plan for zero tolerance and all that. We have this new thing called as, data planes effect on control plane, and control planes effect on data plane, right? So what happens is, so just imagine, so typically, if we plan for some feature called, such as LFA, what happens is, the moment you turn on LFA kind of, pre-installs backup routes. So in effect, what happens is your memory utilization increases. There are certain cases that in certain topologies, you plan for deploying LFA, the memory utilization doubles, right? So now, you have a certain memory utilization, and you plan for this new feature, the, or BGP add path or whatever, right? The memory utilization doubles. When the memory utilization doubles, obviously, the CPU follows, right? So because it's got more memory to now work on. And then what you do, and then on the same corridor, there is an increase in traffic growth, right? So then what happens is, let us say, a particular corridor has a jump in traffic, and you have to add a parallel link. And now you add an ECMP path, or you add a lag. What you will certainly notice if you carefully, do an analysis is adding this lag now again, results in an equivalent jump in memory. So now you had added LFA, and LFA kind of resulted in, increase in memory. And now on top of it, when you add, additional capacity, because you're now planning for a significant increase in traffic growth, you see that the memory utilization still increases, which again kind of results in sort of an increase in CPU. And net what happens is, your planning cycle, reduces even further, right? So this is something, that we have seen, in the Tata Communications network, and this is kind of pretty much a vicious cycle. There is, there's traffic growth, and then there is some, there's this customer's high SLA requirement. So you turn on some new fancy feature, you figure out that now you have to upgrade the memory of the box. Then you figure out that, there's some line card limitations, and now you have to upgrade the line card of the box, and so on and so forth. So it's a sort of a vicious cycle. So that is, that's again one part of the impact, right? So that we'll take note of. So then the second thing that we do, on the Tata Global Network is, we do a lot of network analytics and focused instrumentation. Many using in-house scripts. We just use a lot of in-house scripting to, pull out a lot of intelligent, trending information, for different vendors, right? So different vendors have their own peculiar, eccentricities. So you have to write, it's better to kind of write your own scripts to really do these network analytics and focus instrumentation. So now if you see, so there's a graph, right? This graph really plots, various control plane parameters. So here, you see fib, you see QoS, routing, access, BFD, and then, a few control plane, a few data plane parameters are plotted here. So if you carefully see, you will notice that these are control plane and these are, data plane related parameters. Now, if you carefully notice, there are these blue bars and these red bars, right? On the left side, the red bars are always higher than the blue bars. But on the right side, you see the blue bars are always higher than the, taller than the red bars. Now, what are these? This is an interesting, insight that we got when we did an analysis of, analysis of our network. So we kind of, so the blue bars, right? The blue bars stand for the public domain or the public cloud-based services, while the red, the red color really stands for private domain or private cloud, based services. So what we split our businesses into, private domain and public domain type services. So now what we saw was, the public domain, type services, the public cloud type services or internet-based services tend to consume a lot more data plane resources, than the control plane resources. On the other hand, the private cloud or the private VPN, type resources typically tend to consume a lot more control plane resources than, the data plane resources, right? So typical, public cloud, key features, are the aspects of the public cloud is, on the left side, you see typically a public cloud infrastructure has a lot of 100G. A public domain infrastructure has a lot of, 100G, 40G. It's hot potato routed. There are multi-gigabit DDoS attacks and so on and so forth. On the right side, the private domain infrastructure is a lot more VPN based, right? It's a lot of VPNs. You need fast convergence, and and so on and so forth. So the next slide is really a food for thought, for network operators. So conventional wisdom or the general, best practice today is to converge all networks, be it public cloud, private cloud, or public domain, or or let us say mobile networks or voice network into one global, converged infrastructure. Because when you do a lot of convergence, it gives you economies of scale. It gives you the ability to use, share resources across multiple services and so on and so forth. But in our case, what we found was, though convergence is, is a good thing, it helps in a lot of cases, we kind of did a lot of analysis and instrumentation and finally took a call in certain geographies to deconverge the network, right? So that is something new and something different that we did. We didn't do it in all geographies, but we did in, select geographies, and I think it's a food for thought for, all the network operators as such. What we found was after deconverging certain part of the network, in certain regions, we found that it significantly improved the planning cycle. It also helps, people might just, if you look at the drawing, you might feel this particular drawing is much more expensive than this because there are two networks here and there's just one network here, right? But again, I think you have to do a lot of, focused analytics. You will figure out that in certain regions, it might be better to do this. It might be better to do this, economically, from a planning perspective, and also, from a technology standpoint. Also, you will feel, you might find, I'm not saying you will, but it depends on your network, that both of these models, have their own pros and cons, and so this is just a food for thought, right? So I encourage the network operators to really look at a lot of network analytics, etc., figure out the right way, to build your networks. The second, trend, the other two trends that I spoke about, one was, DDoS, right? So today we have, several large-scale multi-gigabit DDoS attacks. People talk about 2,500 large DDoS attacks happening every day. About 2.5 million attacks happening every year, right? So this one slide really talks about how a DDoS works quickly before I get into some best practices on DDoS. So DDoS typically has, there is an attacker, right? So he's the person who's going to really launch the DDoS attack. And then there is this bot herder. So he's the person who really controls all the computers, all the infected computers that are going to really launch the DDoS attack. So then there is these are the zombies. Zombies are infected computers, virus-infected computers, which are really going to launch this DDoS attack, right? And then here is the poor victim. He's the target of the attack. So all these zombies are going to just launch the DDoS attack on the target, on receiving a command from the attacker, right? So it is, these days you have a lot of such tools, readily available tools. You just have to install it. You can kind of set it up in half an hour, a large botnet, and you can start using it. So the next question is, how do you defend these DDoS attacks, right? So for DDoS attacks, there are commercially available tools. I'm not going to go into a lot of details. They do a lot of behavioral analysis, which is analyzing the behavior of the traffic and then, filtering, DDoS traffic, cleaning DDoS traffic and just sending out, clean traffic. And then, there is blacklist filtering that they do, and, protocol validation, which is kind of trying to see if the protocol, handshake has happened properly, etc. And then a lot of application layers checks, right? So there are a lot of vendors who really have DDoS mitigation, solutions. Now, we come to, so the main point that I wanted to convey was, now there are two options for DDoS mitigation. One is cloud-based, which is DDoS mitigation, from the cloud. The other option is deploying DDoS mitigation in premise, right? So you can buy an equipment from the vendor and then kind of do DDoS mitigation. Which is better, right? That's typically a question that people have. So in-premise DDoS mitigation infrastructure are just not, a good way, are not a good way of kind of doing DDoS mitigation, right? So why do I say this? Why do I say, in-premise? It's not like, there are pros and cons of in-premise and on the cloud. 90% of the cases, doing it on the cloud is always better than doing it in-premise. Firewall, IDS, and IPS, and antivirus are a different thing, but DDoS is a different thing, right? Why? Because in a DDoS attack, you see, there are zombies distributed across the globe, right? So there are zombies in US, there are zombies in, Europe, there are zombies in, Africa, and the Middle East, in China, etc. And everyone is trying to attack a particular computer, right? Or a particular website, or a particular, or a particular service provider, or so on and so forth. Now, if you just filter the DDoS attack just in front of your server, so what happens, right? You have only filtered the last mile. You've only filtered, the attack to the server, but then the attack happening all over the internet, over your local lease line, etc., is something that you have not filtered, right? So deploying DDoS mitigation solution as an in-premise, hardware, is typically, not a good practice. So Tata Communications, we have a globally distributed scrubbing farm. We have scrubbing farms in US, in Europe, in Asia, and so forth. So what we do is, instead of scrubbing it just in one region, when there is a global attack that happens in multiple regions, we kind of filter the attack locally in that region and only send clean traffic, across the internet, to your local loop and to the server, right? So we kind of filter it at the source, instead of filtering it at the destination, right? So that is that is a clear recommendation, right? DDoS, always do it on the cloud. IDS, IPS, and other things, you can do it on the cloud or you can do it in premise. It depends on a case-to-case evaluation. So then I think I'll kind of quickly move on to the next topic. I think in Anycast, on-ramping is again a technique that helps Tata Communications, really scale the DDoS infrastructure. Now suddenly, if there's an attack that's coming from Europe, and you have kind of done the mitigation, and suddenly there's another attack that is coming from US or from any other part of the world, how do you kind of dynamically add these DDoS mitigation scrubbers? So Anycast on-ramping really comes into play. So I think I'll just quickly move on because for want of time. So this is a case study that you can see. This is a large service provider in Asia whose typical traffic, is around 35 to 40 meg, right? That's typical traffic that we see towards that particular, service provider. So now you see that, so we kind of detected a 20 Gbps attack from Europe and American zombies. So you can see that, this is almost a 20 gig attack. Okay. So then, I think there's a graph that really shows, you have these red color, this red color, and there's this green color. Red color is from a different, scrubbing farm. The green color is from a different scrubbing farm. What you can see is, this attack, because it kind of came from multiple regions, was scrubbed, partially in one scrubbing farm, and the other part of the attack was scrubbed in, another scrubbing farm, and the clean traffic, was delivered to the service provider, right? So this is what the graph says. Okay, so now I think the final topic, coming to IPv6, quickly. So at Tata Communications, we have been deploying IPv6 for more than 10 years. It kind of started, the initial trials started, as early as 1995, as you can see. I'll quickly move on. So this is our, global IPv6 footprint. We are number 6 in North America, number 5 in South America, and so on and so forth. So this is our global ranking, as you can see. Europe number 7, Asia Pac number 4, Middle East number 2. In terms of IPv6 penetration. So we can also see that here are quick few statistics. After a long wait, there's been some good traction on IPv6. You can see that there has been some spikes on the internet since the World IPv6 Day. I'm sure you're all aware of the World IPv6 Day, and then the following year, a lot of content providers have now turned on IPv6 natively, and we are seeing a good amount of at least a healthy amount of traffic globally. You can see a 20 gig spike, which I guess would be is most likely a DDoS attack on the IPv6 network. So okay. So again, a couple of learnings, before I wrap up on the IPv6 deployment journey. When we are deploying a global, IPv6 network, specifically from a Tata Communications standpoint, we have a global network, right? So we have to deploy a regional, IPv6 architecture. Typically, when people deploy IPv6, they deploy a 6PE based, based model, wherein the PEs are upgraded first. And so it's much more seamless, to deploy. So Tata Communications, we don't deploy a 6PE. We kind of deploy a native IPv6 end-to-end. That is basically because, 6PE again, there are, I wouldn't say limitations. There are vendor to vendor, the 6P deployment is not fully standardized when you try to deploy it on a hierarchical model, right? If you want to deploy a hierarchical 6P model, you will hit certain roadblocks because of the way, vendors, if you have a multi-vendor network, and if you're trying to deploy a hierarchical IPv6 architecture, you will find, certain issues, which, we can definitely discuss offline. So what we do is we kind of deploy an end-to-end dual stack global IPv6 backbone. We deploy an IPv6 IGP and an IPv6 BGP, a hierarchical model. As you can see, so we have a global set of route reflectors, and then we have regional route reflectors aggregating, to the specific region, and so on and so forth. So, On the dual stack IGP deployment, so we deploy ISIS, as the IGP. So ISIS has multiple options, right? So one is, an integrated topology view. What this means is, if you have V4 and V6 deployed on the same network, right? The V4 topology and the V6 topology will look the same, right? Because the router runs only a single SPF algorithm for both V4 and V6. As against, you also have a multi-topology view, wherein V4, can have a separate topology and V6 can have a separate topology, which means that if there are certain links where you don't want V6 traffic to flow, and you only want V4 to flow, and if there are certain, links that you want only the V4 to flow, such things can be are possible only if you deploy a multi-topology option. Multi-topology option, what happens is there are separate SPF runs that happen for V4 and V6, right? So we again deployed multi-topology ISIS mainly because we deployed IPv6 quite some years back, about almost 10 years back, and we kind of matured the implementation as vendors matured their implementation. So we had we kind of we needed tools that could avoid certain hardware on the network while we are evolving this IPv6 deployment over the years. So I think with that I come to the summary. One is the first item that we spoke about is innovation as network engineering is being driven by challenging global network trends, right? Which is such as exponential traffic growth and zero tolerance. This is something I think almost all service providers are now seeing, right? So you're seeing absolutely exponential growth, I would say doubling traffic growth year on year, thanks to the YouTube, Facebook, and Netflix phenomenon. The second point was network analytics of control and data plane, uncovers interesting perspectives related to technical behavior of various market segments, etc. So, network analytics and focused instrumentation are one of the key pillars for building your network, right? So you should, I think we have benefited a lot by deploying a lot of custom network instrumentation, network analytics on our network. Tackling today's multi-gigabit DDoS attacks is best done using globally distributed intelligent DDoS scrubbing infrastructure. In-premise DDoS mitigation infrastructure are just not an alternative, right? So since we started our IPv6 network journey about 10 years back, we had several learnings, and that prompted us to deploy a unique global, dual stack backbone. And finally, one key recommendation is to build your network infrastructure not based on generic best practices, but based on in-depth, contextual analytics, focused instrumentation, and technical and business merit, right? So thank you, and happy innovating for your network. Thank you very much. Any questions?
Okay, thank you, Raju. Any questions?
So, hi, Massimiliano
Hi.
Stucchi from RepNCC. Sure. So, is there any reason why you're using ISIS for both IPv4 and IPv6? Did you explore the chances of using OSPF3 for IPv6, or
No,
because you're using the same protocol for the same?
Yeah.
Same
So
this might be just one single point.
see, another thing I would like to share is, so we have different global networks again. In one part of the global network, we use ISIS, and the other part we use OSPF. It was not because we made a decision to go, ISIS here and OSPF here because of IPv6 or anything. It was just that we started with ISIS on that network, and we started with OSPF on this network, and that's how we started. But ISIS, I think, has definite advantages, right? With IPv6 because they have, as I said, they have the multi-topology option. You can just turn on IPv6 on the fly. For OSPF, you have to turn on another routing protocol, right? OSPF v3 is a completely, completely different animal than the OSPF v2, right? So it's a completely different. So in fact, the OSPF not a part of the network. We still run on 6PE, but on this network, we have kind of managed to do it very quickly because it's a very quick process, and and there are as I said, definite advantages, right? And you can do multi-topology and all that.
So Philip Smith, following up from that, would you recommend other operators to follow your example using ISIS rather than doing the OSPF or OSPF v3 mix?
Yeah, so I mean, ISIS definitely has advantages, so it's much more easy to deploy, and there are a lot more, I would say, protocol additions that are happening to ISIS. There is v6. There's also a lot of layer 2 enhancements that are happening on ISIS. People are choosing ISIS for, so that way I think, ISIS might be a good choice, but that said, OSPF is also not a very, bad choice, so I guess it depends on your network.
Any other questions? If not, no. All right, thank you very much.
Thank you very much.
Thank you. So next up we have, you can do it. Next up we have Max Stuckey from RIPE NCC, who'll be talking about IPv6 security scenarios.
So